Hey everyone, this is Anne Kloppenborg with your EVTV Amsterdam update. This week at the shop, finally no more boat shows, and I am here sitting in our 818, which now has a set of wheels mounted to the frame, and definitely a moment where it all starts looking a little bit less like a project, a little more like a car. Ray's worked really hard this week, and he's gotten us to the point where basically all the brake lines are installed. All the wheel mounts are done with the suspension arms and all the mountings for the high performance suspension that you get from the Factory 5 kit, and how it goes onto the wheels and brakes of the original Subaru WRX Impreza. Going along with all the brake lines is also clutch lines, so all of the pressure lines basically have been laid. And now that the wheels are on, and pretty soon we'll have the brakes mounted to the wheel, you're getting to the point where you have a push cart, and once we install the transmission and get that all lined out, we'll have a roller that we can kind of push around the business area here and see how we get the wheels lined out and all of that. At the same time, we already got to the point where the steering wheel is installed, and the wheels are turning nicely, by the way, on the original rack and pinion. All these old Subaru pieces were all cleaned up and painted, so everything kind of will come together and look like a shiny new whole once we have it all installed. Right now, the real start of the EV part of the build can also kick off. Mechanically, the EV linkage is always, getting your adapter plate and coupling between transmission and motor, and then versus the motor mounts, getting that going. So we have a setup here in the back that I'll show you while I'm talking, where we have the motor and the transmission kind of lined up. The transmission has the clutch plate already on it, and we can measure out what the minimum and maximum dimensions of the coupler plate are going to be. Now, we don't have the exact figure yet, and we'll be working on that in the coming weeks as we talk about the kind of coupling that'll be from the spline shaft of the Siemens onto the clutch plate of the WRX Impreza. So we'll get that final measurement, but we've seen now that the absolute max is going to be 80 millimeters, 8 centimeters, and the absolute minimum will probably be 6 centimeters, 6 millimeters. So taking the absolute max and accounting for the length of transmission, it looks like we will just get away with getting the Siemens mounted in the frame without having to cut into the frame in any way, and making it basically a drop-in kit for the 818 as it comes with the standard Subaru WRX transmission. Now, this would be a big deal for us, as we've seen that the guys over at EV West have had to make serious changes to the frame to make room for the AC 35x2 that their client requested they install in that system. Now, it is obviously a longer motor, and so they already knew they had to cut through that member, and they did, and change the frame around it. Here also, because of our more stringent regulations as for getting this car road legal, we definitely have an extra incentive to make sure that we have no frame modification needed for the electric kit. Because that would maybe lead to having to do new stress and even crash testing as for European certification law. So yay, that's going to be fun. Anyway, so really looking like we'll be able to fit the Siemens in and make it a drop-in kit for the 818, whether you build it over in the States or here in the EU. And the other thing we're now looking at is to get the ideal amount of batteries into the frame, of course. We are using the Siemens DMOC, and our absolute max and target for this pack is going to be 8 units of 16 batteries, making 8 48-volt units, and having a nominal voltage of around 400 volts with 128 cells and having a charge cutoff voltage at 3.5 times the amount of cells, bringing us to 448 volt top charge, which is also the absolute limit of the DMOC Siemens setup. So these two things will give us about 23 kilowatt hours of battery when we use the 60 amp hour cells. And so I've made a setup of 8 60 amp hour cells that will form the basic module, of which we'll try and fit 8 into the car. We could do 7 and still get, more or less the full power out of the DMOC and Siemens combo. But both for range and for power requirements, I'd like to get all 8 modules in the car, but still have the modules themselves be a standardized unit that we can both use a battery management pack level management system that checks 7 or 8 identical units for variation and gives a little check engine light based on that kind of information. If we do get all 8 in here, we'll also have a good range. Here we're in Amsterdam and we're looking, if we have a range of about 160, 170 kilometers, so that's like 100, 110 miles, that would give us Amsterdam to Groningen, and we're going to make make sure that this car is ready for the 22 kilowatt level of charging, level 2, as it's now being rolled out around the country. Anyway, so that's our 818. We're just at the cusp of making this parts project into a car project, into an EV project, and over the next weeks we'll actually be working with batteries and cables and whatnot and updating you on that. So that's our road-based efforts. This week we also finally had a chance to do some extensive high power testing of the Delta. We had the water, we had our rotation direction of the prop accounted for, we had the day to do it. Alas, the weather didn't really work with us. So we had a westerly wind making the water quite choppy. But all in all, as you'll see in the background while I'm talking, we were able to have a lot of fun out on the water. I think we took her up till about 75% of throttle in the log files we took, and that corresponded in that choppy water to about 55 kilometers an hour as measured by the GPS. So we have the laptop running our logging program, and it's in a rather harsh environment because up here we have the Delta with our trusty pilot Raymond at the wheel, and we're going to try and do one more speed run back home and see what we get. So I'm ready. If you're ready, I'll try and hold all the equipment.
Yeah.
Wait a second. Yep, around the neck.
Okay.
Okey-doke. 3, 2, 1. Doing a good 50 kilometers an hour. We'll have the log file to check what kind of current levels we're drawing. 52 kilometers an hour. I'm gonna hit some waves here. Whee, whee, yeah. Whee. Better go through them. Definitely also making quite a bit of heat in the motor. We're doing about 3,300 RPMs at that power level at 70 kilowatts, doing 55 kilometers an hour. That shows us a couple of things. One, that yes, we do now have this opportunity that when we have perfect weather, we have a prop that can spin up to 5,000. We've done 55 kilometers an hour at 3,300, so possibly we will be touching 70, 75 kilometers an hour on a perfect day. The other side of the story is that now that we have this ability to put all the power to water, we're definitely going to have to start watching how hot the motor gets. and what we can do on that account. So it's good we have our log file systems going. We've had some contact with HBVS recently, as they are very interested in seeing what kind of currents we're drawing, what kind of heat we're generating, as they look forward to starting on a possibly water or oil cool line of their AC motors, getting higher continuous ratings than the current lineup would do as well. And from the Amsterdam warehouse side, I can say we are now locked and loaded for our big shipment that is going out probably from Cape early next week and should be here in Amsterdam before the end of April. It'll be a large load of Better Place batteries, motors, controllers, and a whole lot of the EVTV goodies so that we're stocked again and help you out with your EVTV component fix. Hey, that's about it from us this week. You all keep building. We'll keep building here. We'll get back to you really soon. Take it easy, guys.